All right, let's get right into it. Today, we're talking about something absolutely critical on the factory floor: machine guarding. Think of these as the unseen, unsung heroes standing between incredible industrial power and the people who have to work with it, day in and day out. To really get why guarding is so important, you first have to respect the machine itself. I mean, we are talking about equipment that moves with a kind of speed and force that's almost hard to wrap your head around. And, of course, with that kind of power comes enormous risk. One wrong move, a single moment of distraction, or a missing safeguard. And the consequences can be absolutely devastating, truly life-altering. So let's start by framing the problem. We need to understand the reality of these powerful and, yes, potentially very dangerous machines. Every single year in the United States, hundreds of people are seriously injured or even killed in accidents involving machinery. That's a really sobering number, and it's the driving force behind every single safety rule we're going to talk about. So what are the main threats? Well, safety pros call them pinch and strike hazards. And it's pretty much what it sounds like. You have massive parts coming together, creating pinch points that can crush anything caught in between. And you have other parts moving at insane speeds, creating strike hazards that can cause just horrific impact injuries. Okay, so faced with these kinds of dangers, a very simple, very powerful principle has come to define all of machine safety. This is it, the golden rule. It's not complicated, but it is absolute. If any part of a machine, anything that spins, slides, or moves, could possibly hurt someone, it needs a guard. Period. End of story. So, where do we apply this rule? Well, regulations break a machine down into three main hazard zones. First, you've got the point of operation. That's where the work actually happens, like cutting or stamping. Then there's the power transmission system, all the gears, belts, and chains making it go. And finally, you have any other moving parts. Every single one of those zones has to be guarded. Now, to protect these different zones, engineers have developed a whole arsenal of protective devices. Let's take a look at some of the most common approaches. You can really think about physical barriers in two main ways. On the one hand, you have the fixed guard. This is basically just a permanent wall between you and the danger. It's simple, it's super effective, but you do have to physically take it off to do any maintenance. On the other hand, an interlocked guard is more like a smart door. If you open it, the machine's power cuts off instantly. This gives you easier access, but it has to be perfectly maintained to do its job. Then we get into some of the more advanced stuff. A photoelectric sensor, for instance, creates this invisible curtain of light. If anything, a hand, your arm, anything breaks that beam, the machine stops cold. It's great because it gives the operator a lot of freedom to move. A totally different approach is the pullback device. This is a set of physical restraints that literally pulls the operator's hands away from the danger zone as the machine cycles. It's way more restrictive, for sure, but it's an incredibly direct way of preventing an accident. But look, whether it's a simple piece of metal or a sophisticated light curtain, the goal is always the same, and it's completely non-negotiable. 0 injuries. That is the only acceptable outcome. All right, so we've talked about the concepts. Now let's see how they actually apply to some very specific, very real hazards you'd find on a die casting machine. This is such a great example because it just shows you the problem and the solution so clearly. On the left, you've got these exposed gears. That's a classic snagging hazard. It could grab loose clothing, hair, or a hand in an instant. Now look at the right. A simple fixed guard has been put in place. The hazard is still there, but now it's completely walled off. Problem solved. Now this right here, this is something known as a bursting biscuit. It might just look like a weird piece of scrap metal, but it's actually the result of a violent failure inside the machine, where molten metal explodes outwards at incredibly high velocity. It is an extremely dangerous event. So how does this even happen? Well, molten metal gets injected into the die, and then a plunger applies immense pressure. The problem is, if that metal hasn't fully solidified and the die opens, all that pressure has to go somewhere, and it goes outwards in an explosion. So the solution has to be an engineered one. You need a super strong interlocked operator door that's built to contain that blast and designed so it can't open until all that pressure is gone. And this just brilliantly illustrates the kind of precision that goes into this. I mean, sometimes a guard needs an opening, right? But those openings are very strictly calculated. The principle is simple. The closer the opening is to the hazard, the smaller that opening has to be. You can see right here, if you're just 1.5 inches away from the danger zone, the biggest opening you can have is 1/4 of an inch. Way too small for a finger to get through. But all the best engineering in the world is only one part of the safety equation. And that brings us to the final and maybe the most important safeguard of all. And that final safeguard is the operator. It's the human element. Simple rules like don't wear loose clothing, never ever tamper with a guard, and always make sure guards are put back after maintenance. These aren't just suggestions. They are absolutely critical safety procedures. Proper training, knowing how to shut down the machine. That's what makes the whole system actually work. You'll see signs like this all over a factory. They're clear, they're direct, there's no misunderstanding them. But at the end of the day, a sign is just a warning. The engineered guards provide the protection. But real safety? That comes from a culture where every single person makes the choice to work safely every single time. So that really brings us to a final thought. We've spent this whole time talking about how guards are there to protect people. But that leaves one last critical question. Who protects the guards? And the answer is everyone. It's the maintenance crew that keeps them working correctly. It's the operators who use them properly. And it's the management that builds a culture where safety is never, ever compromised. That's what keeps the heroes of the factory floor on the job.